discuss about Bombelli solution. But before looking into Bombelli solution, I would like to recap a little bit on Cardan's problem. This is because there is a link between Cardan and Bombelli. Cardan faced a problem and Bombelli provided a solution. What is Cardan's problem? Cardan was facing problem in finding roots of cubic function. He knew that there was a solution for the cubic problem, but he just didn't know how to deal with the square root of negative number that keep popping out in his equation. He knew that there will be a real value as the root of the cubic function, but he couldn't find the other two roots due to the presence of square root negative number. Square root of negative number asks us to find a value that when it multiplies by itself, it can get back the negative value. But here comes a problem, because neither positive or negative number will work. When positive number or negative number multiply itself respectively, the resultant answer will always be positive. We can never get back the negative value. For example, the square root of 9 we can get by multiplying 3 times 3 or negative 3 times 3. But how to get the square root of negative 9? What value need to multiply by itself in order to get square root of negative number? Therefore, Bombelli was clever enough to give his first insight for Cardan's problem. Cardan do not know how to deal with the square root of negative number. He don't know what is the value that can multiply by itself in order to get back the square root of negative number, because the value cannot be positive or negative number. Therefore, here comes the first insight of Bombelli. Bombelli agreed that if positive number or negative number won't work out for the square root of negative number, he just simply accept that there may be some other kind of number will solve the problem.
To name this number, Bombelli just simply let the square root of negative number be their own things. Thus, here comes our value that being named as square root of negative 1. When we square the square root of negative 1, we can get back negative 1 as our answer. However, we can finally got a name for the square root of negative number. But this is still not enough to solve the Cardan's problem, which is how to find out the other two roots in order to solve the cubic equation. Therefore, here comes out the Bombelli second insight to solve the Cardan's problem out. Before we look at another Bombelli solution, we look back the example of cubic equation and the solution solved by using Cardan's formula. The problem of this solution is it contains square root of negative number, thus it is unable to be calculated. Therefore, here comes out the second big insight of Bombelli solution, which is the root of the minus 1 part of each half of the equation must cancel out when they are added together. Each half of equation 1 can be written as this form, which is equation 2 and 3. A and B are the constant which we have to find out their values. Below is another form of equation of x wrote by using constant A and B. First, we have to cubing both sides of equation 2 becomes equation 4 and also equation 5. Look back the original equation. We test it by substitute x with few integers, and this is the solution. By putting the value of x into this equation, we can obtain the value of a and b. This is our x equation with constant a and b. We can do some checking by cubing both sides, and the result that we get is same as the previous equation. Therefore, it is proof that the Bombelli solution is true to solve this cubic equation. There is an interesting thing. This is our problem and solution. We can see that both of them do not include square root minus 1, but it can be clearly seen that square root minus 1 is included in our working step to find out the solution. Therefore, we can conclude that square root minus 1 is crucial to our process in solving a mathematical equation.
So here comes the problem. As we know that the area of a square is length times width, and both of them have the same value. It's logic to have a positive area, but what does a negative area mean? And what is the meaning of square root -1. Such questions have slowed down the development of imaginary number.